afternoon all. Data center maintenance and migration best practices. Again, raise of hands of folks who went to 2611. Okay. So there are certain best, it's a sequel of 2611, it's 2612. There are some best practices that relates to migrations and change window is being, again, it's a recap for few slides, and then we get into the details. But before we get into the presentation, one of the key things is WebEx. Everybody has 2612 in their WebEx app. You can use the WebEx app to ask any questions even during the presentation. It's going to be Anis and myself, we'll be able to answer it. And after the presentation, we would be going to the WebEx app, and also will be open for one-on-one based questions after the presentation. A bit about myself. I'm Arvind Durai. I've been in Cisco CX, formerly known as Advanced Services, taking care of more than 100+ customers in architecture, technology, transformation. But more important was on operational efficiency. How do we operate an environment? And that's one of the reasons Anis and I are doing this presentation, in fact, for the last 7 years. And always we are adding new stuff to this particular presentation. 14 years of active Cisco Live speaker. I have 5 Cisco Press books under my name, from security to scripting to virtual routing in the cloud and IP multicast volume 1 and volume 2, and also currently also a CCI. With that, I hand over to Anis.
Can you guys hear me? Good afternoon, everyone. My name is Anis Edavalat. I'm a senior solutions architect with Cisco CX, or Advanced Service, whatever you guys call it as. 12 years with Cisco. In that 5 to 6 years with CX, prior to that with different business unit, in CME business unit being the last one, where we make NXOS 9K, VXLAN, ACI, tetration, those kind of solutions. Active CCI in data center at the moment. I was involved in almost 50 to 60 architectural transformation projects across different industry verticals. And all the best practices, all the best approaches that we are going to share is extracted from our interactions with those customers. That's the quick intro. Back to Arvind to continue with the session.
Thank you, Anis. Again, the course objective is for data center engineering staff, right? How do we operate the data center, manage the data center for planning a change window, and also we will be going through migration use cases, right? That's the course objective. Now, out here, the things is in the 45 minutes, you're going to, the 3 things if you get, we would consider ourselves successful is, what are fabric best practices? Fabric best practices are important for planning a change window, or even for migration. Migration features and tools. What are the features and tools that we would use for migration? And again, the methodology, because every migration, every change window is an art, right? It's not going to be the same. So what is the methodology out here? So in terms of the agenda, baseline features and tools will be covered by me. Anis would take us to the finishing line with migration methodology and change window best practices. A DC baseline refresher, before we get into this, is VPC terminology. In this case, it's pretty simple. All of us know what is a VPC. S3 looks as S1 and S2. S3 looks at S1 and S2 as a single entity. S3 sends the packets across a distributed ether channel to S1 or S2 based on a local hash, right? Between S1 and S2, you have the pure link and the keep alive link. Cisco Fabric Services exchange the state between S1 and S2, and this is a fully redundant system. In this particular system, if you have an orphan device, it is okay, but this orphan device causes problems to your availability that you already built in, because if you have an application connected to this orphan device, if you bring the S1 switch down for a change window, you're going to have an impact. Pretty simple. In terms of failure scenarios, what happens if the peer link dies? S2 automatically will bring all its links down while it brings the links down, the packets that's already left from S3 will get dropped, the in-flight packet loss. The phenomena, a design feature that really impacts the in-flight packet loss is oversubscription. An oversubscription of 20 to 1, an oversubscription of 2 to 1, 2 to 1 will have less loss compared to 20 to 1. So normally when we do a design, what folks think about as oversubscription is for applications. It is also for change windows and change management for operations. Keep that in mind. In terms of best practice, the domain IDs. The VPC domain IDs have to be unique to avoid MAC flapping. Folks in the end of the room, can you see my pointer? Raise your hands if you can see it. Okay, perfect. I just wanted to make sure. Peer links should be point-to-point or dedicated, and peer KPI live links should have a control plane with dual supervisors or user management. So these are best practices from a hardware and how you tie in and design your environment. Peer gateway feature. When you look at peer gateway feature, if you look at S1 and S2 switch, S2 could forward layer 3 packets that are destined for S1 switch. You might have a load balancer or something that's connected to S1 switch. So this peer gateway is also a command that allows S1 and S2 to function equally from a layer 3 perspective. From a VPC peer switch, S1 and S2 using this command would become a single entity from a spanning tree perspective. So for a BPDU processing, it is a single L2 switch. Distribute your ether channels, again from S3, if you distribute your ether channels across different line cards, you would be able to have that hardware redundancy and have a seamless change window. The change window could be a planned change window or could be an unplanned change window. And map for oversubscription, we went through it. In a change window, if you're going in for a change window, when you're looking at best practices, we highly recommend, if you don't have any of these best practices, to at least enable peer gateway and peer switch command. This is a simple to deploy and has a high impact during your change window. Now let's look at VXLAN, because why we need to understand about VXLAN is when we get into migration scenarios, when Anis goes through, VXLAN is the key thing that you all will be migrating to. Now VXLAN in terms of is nothing but encapsulating a layer 2 packet across a layer 3 overlay. To build the layer 3 overlay, you need to have a layer 3 underlay, right? It is like simple GRE, all of us have been doing GRE. To build a GRE, you need to, so that's as simple of VXLAN. VXLAN, what happens is the VTAP out here, encapsulates the layer 2 packet into a layer 3 packet. And this layer 3 packet is a UDP packet. This UDP packet can be hashed across a fabric, which is layer 3. ECMP hash could take place. That's the difference between UDP and IP GRE. We can do the hashing in this case and split the load across the fabric. The packet gets encapsulated. It goes across from a layer 3 perspective to this particular VTAP, which de-encapsulates the packet, and you get the layer 2 packet back. So UDP, in terms of the VXLAN segment, which comes in, which maps the layer 2 segment, it is a 24-bit segment ID, 16 million entries in terms of tenancy that we could get. 16 million is, what is the VLAN limitation? 4094, right? Multi-tenancy is scalable, supported with this. Now, within VXLAN, in terms of the flavors, we get VXLAN with flood and learn at BGP EVPN. The best practice states that go with BGP EVPN-based fabric. Now, even ACI, we have the data plane for ACI is based on IVXLAN. It is tied in because a little modification on IVXLAN, but it is the VXLAN concept. The control plane for ACI is based on COOP. Now, when you're talking about ACI, before we get into ACI, VPC is still needed. The bottom side of the slide states VPC is still needed because VPC provides high availability to this end host, right, between the leaves. So all the VPC best practices are still leaded out here. Now let's talk about ACI. ACI is what I look is a fabric which has a policy-based construct that could be tied in for a single site, a multi-site. This policy-based construct is based on the FCAPS model, where you have fault, configuration, accounting, performance, and security. A lot of things in ACI, apart from policy, and there are some slides and use cases I will say that there are certain things for operations, it is built in. And we'll go through a few examples of that when we go through this presentation. When you look at an EVPN fabric, which is a BGP, EVPN, VXLAN fabric, you can go with Ansible, or you can go with any type of chef-based tools. It's an external tool that could be tied in. But you don't get the fault, accounting, and performance. And that's one of the cases we recommend customers to use DCNM. And the newer name for DCNM is NXOS Dashboard Fabric Controller, right? It's an app on the NXOS dashboard. So with this, from a profile from ACI, look at the application profile from SLA, QoS, security, and classification. Again, application profile could be a subnet profile that's network-centric. So you take this application profile that ties in connectivity, security policies that's there in the fabric, QoS, application layer 4, layer 7, how you sandwich the firewall or any type of security instance, and storage and compute. You tie this all in a policy together, and then it is applicable to your application. That's a three-tier application, and APIC then takes the policy and puts it across the whole fabric. This fabric could be a single-site fabric or a multi-site fabric. It could be within your on-prem or in the cloud. Examples when Anis goes through migration use cases, we will go through difference between a single and multi-site in terms of the policy model. And your hypervisor layer in this could be anything else. So that's from an ACI side, an intro on ACI. In terms of best practices, one thing which we need to understand is I'm planning a change window, I'm planning a migration, understand what are my layer 3 best practices, what are my layer 2 best practices, and hardware best practice. As you can see, if you have your hardware and layer 2 best practices already tied in, link failure, node failure, NSF, SSO is sub-second. Now, if in layer 3, if you don't have optimization in layer 3, what happens is your layer 3 might take around 5 seconds amount of planning and the hardware you have spent for hardware best practices, the cost you have spent for hardware best practices, you will not benefit if layer 3 takes a longer time to converge. So your node's recovery is based on all these best practices that's tied in. So for OSPF or layer 3, it is recommended to enable BFD and also SPF timers, which is for ISIS and for OSPF. So enable that and get a complete, your topology from a layer 2, layer 3 and hardware will be below a 1 second, a sub-second convergence that you would be able to get. And this is important because if you have an unplanned outage, crash that doesn't suddenly takes place, how do you understand the in-flight packet? How do you plan on the convergence of that particular node in the topology? These are things that you really need to take into consideration. Now let's get into, from best practices, get into change windows. The basic concept of change windows is, again, isolation. Isolation of a node is dependent on the features, and let's start with the layer 3. In the layer 3 portion, what we want to take is the concept is pretty simple. I want to build my control plane, and then I want to make sure my data plane is advertised in such a way that none of the routes come back, or it's been advertised as the highest way to reach the destination. So basically, you can take the node off. But for us, from a data center engineering staff, we really don't have to worry about the protocols and the features. Use the CLI parser, isolate. Isolate from a BGP, make sure it discontinues all prefixes. Isolate from EIGRP, ties into max K values. Isolate from OSPF, ties to max metric LSA. And isolate from ISIS, sets to overload bit. So just use the isolate keyword to isolate any routing protocol. And again, to get the device back from a layer 3 into the topology after the change window, use the keyword no isolate. Simple. One of the things is when you do a no isolate, okay, when you do the keyword no isolate, the control plane is still maintained. So you remember when we went into the isolation mode, the control plane is still maintained. When you do a no isolate, the control plane is still maintained. The protocol is advertised from the neighbor until it gets installed in the hardware. The device does not move from a no isolate state. So we wait for the protocol to tie the route entries in the hardware, and then that's when we bring the device back into the action. So again, this is all done automatically. It's just the things that we have thought about in terms of how we bring back the device to the topology. VPC shutdown, all of you are familiar with VPC shutdown, but prior to 6.x release, I'm dating back years back, what we used to do is shut down the downstream link, shut down the peer link, and the keep alive. We used to go with a sequence to have the minimize effect to VPC shutdown. In this case, do the VPC shutdown, and automatically from a layer 2, you can get complete isolation. And if you want to bring back from a layer 2, bring back the device into the topology, do a no VPC shutdown. Features matter. In this case, I have feature OSPF and VPC. What I would do for OSPF for isolating is I use the isolate keyword to invoke max metric LSA. And also from a VPC shutdown, I would invoke and isolate a device. But then if you have a lot of features, you have to use a script to make it do the device isolation faster during a change window. Instead of doing scripting, what we could also do is use graceful insertion and removal command that is system mode maintenance to isolate a device during a change, and then after the change, do just a no system mode maintenance for the device to be brought back into the topology. The protocols, the way the data plane will shift will be based on how protocols tie into the device, right? But the device will be active in the topology. So GIR, again, we are network engineers. So we have choices out here, automatic profile and manual profile. Automatic is generated by the system. Manual profile is custom profile that will be. So we'll go through what is automatic and what is a manual profile. This is a CLI parser of a automatic profile. So in this case, if you do show system mode, in this case it's normal, and then we go into system mode maintenance. When you do system mode maintenance, the CLI parser would go through the config, understand what features have been configured, and then verify from the admin if you can shut down the feature. If you say yes, then what happens is it isolates the complete feature out here. And then it gets into maintenance mode. The next one is a custom profile, which normally is a service when a device is, a node is connected to the firewall or a load balancer service block, or it's a leaf where you have a defined fix connection, we would go ahead with a custom way. In custom, you can add sleep commands, and also you can exclude fabric, so you can be more meaningful based on the customization that you want. For every custom profile, you need to have a profile that's been a template that's been written to come out of isolation. And also don't forget this particular CLI, do not generate profile to be enabled when you're doing custom. The other thing is, if you have a chronic issue for an unplanned change, you're troubleshooting your environment, and you call up TAG says, could be a problem, let's investigate further. We have seen in those occasions, if you have two switches and one switch is having this problem, go ahead with system mode maintenance on reload set and give the syslog message that you want it to do. So automatically if the syslog comes for that device, it gets into a GIR state, and you can have a timer to schedule the GIR state also. So kind of this makes it for unplanned changes. Make sure you don't enable this across all your switches in the fabric, because if you get a syslog message, all the switches will go in. So only tie it to a switch if you have a chronic problem, and not to the peer switch, just to a single switch. And this could be a VPC primary. Snapshots before a change window, create snapshots. Once a snapshot is created after the change window, you can create another snapshot to compare. The comparison is shown in this, where you have a comparison before the change window to after a change window, and you can verify the parameters that has changed. And you can drill down into some of the metadata out here, in this case, the IP route, and verify, in this case, 33, and you have only 3 routes out that has been shown. And you can also get the details of the routes which has not been shown in post change. Verify those details. So these are tools that we could use that's already built into the NXOS software feature. Data center controllers. Again, controllers is the key thing that you would be going from a current state to a next transformed state is going to be with controllers, whether it's the EVPN fabric with VXLAN or ACI. So with controllers, this is a unified view that we would always like everybody to have with controllers. You have controllers out here for ACI is APIC, DCNM, or NXOS Dashboard Fabric Controller. The next version of DCNM is called that. I mentioned it a couple of times. It ties up to an orchestrator piece, an inside speaker as a broker, data broker, that ties it back to an NXOS dashboard. Now, what's important out here is to understand benchmarking. How benchmarking works, upgrade planning, and pre and post change window baselining. So from benchmarking, from a health score benchmarking, upgrade planning, and pre and post change window baselining. We'll go through some examples, and Anis will also cover this more in the migration step. In this case, you have faults. These faults are health scores, which is in ACI or DCNM. It could be faults based on packet drops, microburst. Microburst, I've never heard faults based on microburst, macro drops. Also, in terms of features that TAC is seeing, in terms of errors, hardware-based errors, all these could tie into faults, and you can even have custom faults written based on your best practices for your environment. These faults could have an aggregated view or a fabric topology view. So all controllers, whether it's APIC or DCNM, would provide this view for you based on your health scores. Now, the next thing is upgrade. When you're doing an upgrade practice, especially let's take ACI's example, you upgrade your APIC with the right release. Once you upgrade the APIC with the right release, there's something called maintenance groups. Create maintenance groups and then bring in switches in the maintenance group. If you have a row which has switch A and switch B, always put switch A in maintenance group 1 and switch B in maintenance group 2. By invoking maintenance group, all the best practices of GIR and everything is already being put into maintenance group. You don't have to worry. Just take the switch and put it in the maintenance group, and it's taken care. The next one is DCNM. In DCNM, you do have templates, but what you have to do is you have to take these templates from the library and customize it. The first time you use, you have to customize it for image, config, patch, and GIR. Once you do that, then you can reuse it multiple times. So you need to take those templates, create the templates, verify those templates for your topology, and then multiple times you can reuse. In terms of snapshots, and this is something NXOS Dashboard Fabric, NXOS Dashboard does. It takes all these health scores from your APIC and DCNM controllers, ties it for pre-change and post-change. It ties all the faults. You can have custom snapshots based on routing and all those type of information you want. You can have that and do a comparison. And this is done based on NXOS dashboard. So with that, I will hand it over to Anis for migration.
Thank you, Arvind. Before I start with the migration best practices, can I see a quick show of hands? How many of you guys have been involved in any kind of strategic transformation of your data center architecture? Wow, almost everyone. Okay, so let's get started with the best practices. The most important thing is your strategy and approach. Any strategic transformation will have a source architecture or your current state architecture, which will be transformed into the next-gen architecture. In Cisco technologies, those are your VXLAN fabrics or ACI-based fabrics. But irrespective of your current state or your target state architecture, the phases, approaches, the activities that you need to perform, that remains pretty much the same. We start with analysis and planning phase in stage 1, and then ends with post-migration application monitoring, application performance monitoring, so that we can set the stage for continuous improvement in our network environment. Continuously, we can improve it. Now, what are the individual actions or activities that we need to perform in each of these stages? We know that we are going to do an architecture transformation. So architecture governance board need to have proper representation from your security team, app team, and from your network or infrastructure team. Once we have that, their responsibility is to solidify your architecture by considering all your scale requirements, latency, and performance requirement. Next step is to get to know about your app, visibility into your application environment. How many of you guys have dealt with Tetration Analytics or Cisco Secure Workload? Very few. And then how about App Dynamics? Okay. So these are the two prominent tools using which you can get the dependency mapping between your applications, or there can be any other custom application performance management tool. You can use any of those tools and then get visibility into your environment. Why is it important? Because it is the application owners and the end users who are going to traverse your network, they will be blaming the network first. We don't want that. Okay. Then once we get to know about our app, it's about planning the migration strategy. My preference is parallel migration. Parallel to your existing legacy environment, start building your target state architecture and then build it, and then start moving your workloads onto that target architecture. For that, documentation is key, because while you're performing the migration during the D-Day, we won't be thinking much. We will just be replaying what is there documented, reviewed, and approved by our change control board or our architecture management board. And then we move on to APM monitoring, so that we can set the stage for a continuous improvement. Every transformation includes dependencies or interdependencies, especially in the data center, okay? And then, if you know your business processes, how it is tied to your application, you are taking a top-down approach. If you know your servers, your networks, and then how that ties back to your application components, that's a bottom-up approach. Now, applications can be tier 1 and tier 2. And we know that no two apps are the same. There is no wonder drug which is going to fix all your app-related network interaction issues. So the bottom line is, we need to know at least 80% in a consolidated manner, top-down and bottom-up. We need to have a consolidated view. If you know 80% of this, then we are pretty much covered. If we know less than 50%, that's a big risk that we are taking. So try to set the stage right. So enough of planning and strategy. These are the important use cases that we all deal with. Okay? Application, we will start with the visibility options. Then we will get into, okay, how can we connect between our legacy infrastructure and the modernized infrastructure? When and how to migrate your gateways. That's the third thing. Then we will get into site-based considerations. You will get into this scenario if you end up using all your ports, and then how can you scale horizontally? Last but not least, if you're moving to ACI, what are the constructs-based considerations? Let's start with visibility. Application dependency mapping, which you can obtain again from Tetration or Secure Workload or NXOS dashboard, will give you detailed information about how specific group of servers are related to each other in terms of what are they communicating between them, what type of ports and protocols are open between them, what are the things that you need to consider for grouping servers into different server groups or endpoint groups depending on the technology you are migrating to. With this information, we can very well do the workload migration. But the key is, if we know this information as well, that is application flow mapping, that will help us to set a benchmark which you can use before migration for planning, during the migration to ensure that things are working fine, with part of the workload residing in your legacy and other part residing in your modernized infrastructure. And then even after migration, you can prove to the users that, okay, you guys are getting a better performance of your app with the new modernized infrastructure, at least the same performance as before. It cannot go down. From there, we move on to how we can connect the two networks together. You have your legacy infrastructure, which consists of your collapsed core or separate core and distribution. Then you have your modernized infrastructure. I have chosen EVPN VXLAN over here. What is the first thing that we will do to connect between these two? To ensure seamless workload migration, we need to have a dedicated layer 2 connection between these guys. Now, when a dedicated L2 connection is made, you need to be careful that we are not introducing any kind of loops or spanning tree issues. So careful planning of all your root bridge placement need to be done, and that normally is done here. And then, once we have that, then the next step is you go ahead and create your L3 connection. The best practice is to have dedicated pair of layer 3 gateways in your new modernized infrastructure, which is here, and not in VPC. Okay, keep in mind here it is back-to-back VPC, L3 is not in VPC, and then have dedicated connections. The important thing we need to keep in mind is, okay, never enable any kind of summarization in both these places. If you guys have attended yesterday's session, we have asked for enabling summarization after you migrate, but during migration, this is the key thing to keep in mind. No type of route instabilities we can afford during the migration. Last but not least, you might be having overlapping VLANs between your current state and your target state. Simple VLAN translation that can be configured on your distribution here. Now you have an environment like this with L2 and L3 connected. Let's talk about how we migrate the workload and after that migrate the gateways. The first thing is our initial gateway is residing using HSRP, VRRP, whatever protocol of your choice in your distribution or in a collapsed core. Then we will start performing the migration of the workload. Workloads will be migrated one by one from your legacy infrastructure into your modernized infrastructure, but still the gateway is residing here. Once we complete the workload migration, that's when we will shut this gateway down, and then you enable your distributed anycast gateway. You might ask a question, what is distributed anycast gateway and what is the benefit that I will get if I move to DAG? Now what it gives you is seamless mobility between your different switches, because every gateway is going to have same IP address and same MAC address. Okay? Let me ask you guys a question. When do you guys migrate your gateway from legacy to a modernized architecture? I'll give you 3 options. Option number 1 is pre-migration, that is before migrating any workload. Option number 2, after you migrate 80% of your workload. Option 3 is post-migration. Anyone want to take a chance? Yeah. Number 2, absolutely, that's my perfect answer and that's my option as well. But I'll give you a different view as well. I have done pre-migration in one scenario when we were doing deployment and migration for one of the largest software as a service provider in North America. What we have done is we did pre-migration. The reason is we were not migrating any services. We were not migrating firewalls, load balancers, or WAN optimization gateways, nothing. Those were deployed as greenfield. In that scenario, we don't have to worry about any service related issues. We can go for pre-migration. But for every other scenario, this is the preferred approach and this is the recommended approach. You can choose between 70 and 80%. 80% is my number. It's up to you guys to choose the number. But the bottom line is, after majority of the workload is migrated, that's when you will do this migration. Okay, for scaling out, let's take the case of ACI data center as an example. You ended up using all the ports. Now, what are your options? You have an ACI data center over here. My immediate option is think about multi-pod consideration. Now, multi-pod means nothing but you extend your APIC to a new data center or a new location or a new room, and so that you can use the same policies that you defined in your primary data center, and then build your fabric, and then connect these two data centers using your layer 3 connection, and this is called your interpod network. Imagine the use case that you want to go for an availability zone type of deployment. That means you want to have a dedicated DR. You don't want to share the management plane. No orchestration plane need to be shared. The option is go for multi-site deployment. The dependency here is these switches, the spine switches which are connecting your inter-site network, that need to be cloud scale ASIC FX series Nexus 9000 switches, which is capable of translating between your sites. Okay? What if you're not doing ACI, you're doing EVPN VXLAN? Again, the approach remains the same. The thing is, there is no multi-pod over there. We will be using multi-site using a dedicated gateway called border gateway. In order to know how we can migrate ACI from a legacy network, it's important to understand what are the constructs of ACI. In legacy network, we have VRF, L3 construct, L2 construct VLAN, then you trunk the ports to the servers, then you extend your VLANs all the way to your hypervisors, then you do the routing configurations. In ACI, the highest level of abstraction that you are getting is your tenant. You can say, okay, my customer, each customer is one tenant, each department is one tenant, and so on. Then comes your VRF, same like our legacy network VRF. Then comes bridge domains. Bridge domains are nothing but an equivalent representation of our VLANs in legacy environment. The new construct is EPG, that is a group of servers, or BDs can be attached to EPGs. Then comes your layer 3 out construct, which will connect to your L3 out. Then comes application profile. Application profile is going to group together all your EPGs. So this is a very high level, quick refresher about how legacy network can be mapped to ACI. Now let's take a look how legacy network can be migrated into ACI. Left side, what you are seeing is my legacy network. I have VLAN 10 with this subnet, VLAN 11 with 10.10.11.0 subnet. I have two hosts here. I did a parallel deployment. I created an ACI fabric. I created corresponding to VLAN 10, light blue, I created BD blue 1. Corresponding to VLAN 11, I created BD blue 2. What's my first step as per our 5-step process? Interconnect. Create L3 interconnect between your core routers and the L3 outs. Run any routing protocol between them. Again, no VPC, dedicated connections. Second, extend your layer 2. Again, this need to be a VPC back-to-back. After that, start moving your workloads. Add tags, aliases. These are all things which we covered in yesterday's session. If you guys have not attended, feel free to go back and check why tags are required. And then move the other host, and then once you migrate majority of the workloads, you migrate all your services and migrate the gateway from your legacy network into your ACI fabric. Same approach, there is no difference. Only thing is you're doing ACI instead of VLAN, instead of VXLAN. You just need to worry about the constructs. Let me introduce this thing, border gateway EVPN, EVPN border gateway. Now, you might be wondering when you heard EVPN and border gateways and all, this is only for VXLAN. Yes, the primary purpose is to interconnect two VXLAN domains, but this is represented here as a replacement for a traditional data center interconnect. You might be having VPLS, you might be having OTV. Instead of that, if we can utilize this simplified solution, this will lay the foundation for converting your legacy infrastructure into an EVPN VXLAN or ACI. Why should somebody go for it when they already have a DCI? When it's time for you to refresh, this is a good step that you guys can take. Insert two BGWs or border gateways in your environment, because this provides control plane and data plane separation and seamless interconnection by utilizing any transport methodology. This provides ECMP load balancing because this is layer 3. This provides multi-path capability, okay? And this is a cost-effective solution. When you guys are about to take a decision, we can talk about the costs, connect with any of the Cisco counterparts. Let's take a look. How can we interconnect and migrate? You have two legacy networks, okay? Those two legacy networks, the first step is introduce a pair of border gateways to legacy sites. This is called VPC BGW, which is connected in back-to-back VPC to your distributed environment. Next step, connect these two sites together. Simple routing. What routing protocol you guys will use to connect these two data center sites? You can use any routing protocol of your choice. Is there a recommendation from Cisco? Yes, we do recommend eBGP. Because for the overlay, the next step, eBGP is a mandate. Once you have the connection, then you go for your overlay network, and that establishes your BGP EVPN control plane between the two sites. Now you can talk about, okay, what VLANs that you want to extend. Let me ask one question. How do you handle storm control when you connect two networks like this together? Is that a problem here at all? Am I doing L2 and L3 separate connections? No, that's why this is so simple to connect. Everything is taken care in VXLAN for the data plane and BGP EVPN for the control plane. There is a feature called EVPN storm control, which can limit how much of a bump traffic can be extended from one site to another. Okay? Gateways are again residing in your legacy network. As you can see, the HSRP gateway is up, Anycast gateway is down. Even before migrating your workload, you can change the gateways because this provides gateway functionality for every legacy host too. Okay? When it's time, reverse the role, shut down your HSRP, bring up your Anycast. So we have this setup now. Your two legacy networks are connected to each other. We have not yet built the VXLAN network. Just go ahead and then build your VXLAN spine and leaf architecture, and then start migrating your workload. It's very simple because your gateways are already migrated to BGW. You can even connect hosts to your BGW so that even if you don't have this, you can do all your testing, whether your application is going to work, all those things. We don't want to recommend people to run with their migration approach. What I would suggest is there are two approaches. You can go ahead and do a rip and replacement, or you can take the approach of crawl, walk, run. Which one do you guys take? First one or the second one? Obviously, second one. So that's what I'm saying. If you have this type of an environment, you can connect some hosts here, some of your application servers, and then test your applications, whether it is going to work right. Okay? Once you're done with this, migrated the workload, simply remove your old fabric, and then start managing it with Nexus dashboard. Pretty cool, right? Very simple. We have dealt with some of the migration scenarios. Let's talk about change management. Change management, usual change management practices. We have a change management board. Change management board need to approve your changes, and then you will go ahead and then implement that change, and then you will take a decision whether it's a go or no go, right? Imagine a VPC scenario. We have L3 core over here and then access layer here. For making any changes to your VPC environment, first we need to do the isolation. How do you do the core isolation? Arvind explained the golden feature. I call it as golden feature, GIR. Using GIR, you can isolate one of the VPC peer, take it out from the active forwarding path, and then you might be either modernizing it, you might be bringing into a new technology altogether. Whatever be the change, use GIR. Then comes your access isolation. Access is going to be VPC or L2, and you will end up having three different scenarios here, either directly connected host or active connected FEX or straight through connected FEX. If it is active connected or dually connected direct connected host, we are covered. We can do one by one by removing one of the VPC switch. If it is straight through, plan for a downtime. If it is only for a software upgrade or software fix, the tools that you need to use is ISSU or SMU or software management update. That is only for bug fixes, PCerts, field notices, simple fixes. Without upgrading the image, you can use SMU. Similarly, in an L3 environment, core isolation can be done by using graceful insertion and removal, GIR feature. But access isolation, here you have layer 3. Okay, this layer 3, you don't have to use the VPC methods. Instead, what you can use is same GIR can be used. But anything southbound of your access layer, again, same considerations, whether you have straight through FEX or active-active FEX or directly connected hosts. In summary, always try to use data center network controllers. All the best practices, configurations have been codified and then added to DCN controllers as templates. You can just simply consume it for playing around or take it and edit it as per your local requirement. GIR. Use GIR for isolating any of your migrations or maintenance windows. And last but not least, leverage all the migration methodologies that we have used over here. Before we conclude, I have a question. How many of you guys were involved in a 5-hour change window? Can you please raise hands? We have a lot of people. 10 hours? Okay. 15 hours? 15 hours, 1, 2, 3, 4. 18 hours?
Got 2 hands.
No, 3. 1, 2, 3, 4, right? 5. 20 hours? 1 day, 24 hours? Oh man,
We have 1 hand out there.
1 here, 2, 3, right? 30 hours? What is that you have done, maximum? What is the maximum change window that you have done? 24, you, 24. How about you? 24.
We have gifts for the Hall of Fame for change
We have
windows.
Hall of Fame, some gifts for you guys. Arvind, can you please?
We'll give it after.
We'll give it after the session for you guys, okay? Okay, so these 3 guys are your Hall of Fame guys for change window because we have a lot of expertise in this room. We know how to handle a change window. Congrats to all the winners. Last but not least, we take the service very importantly within Cisco. Arvind has been doing this session for past 12 years, and I joined him for last 5 years. And then the feedback from you guys are giving us input about, okay, what need to be included in these kind of sessions. Of course, we get from our customer interactions, but the feedback from Cisco Live is taken with utmost importance. And regarding the score, if you're hovering between a 4 and 5, we will happily take 5. That will help us to come back and then present the content that you guys want to listen to. Okay? For continuing your education, again, we know that 45 minutes, even for a topic like BGW, we cannot do justice to it. Okay, so we have given you a sneak peek or preview of all these technologies. To continue the education, utilize the options like capture the flag, walk-in labs, instructor-led labs, other breakout sessions. Please utilize these things and then continue your education journey. With that, I wanted to thank you guys for attending our session. And then Cisco Live is only just 2 days old. We still have 2 more days to go. Hope you guys are having a fun time here. Enjoy the Cisco Live, and we are open for questions.